Thank you. Wow. What a welcome. So thank you so much to coming to my presentation where you're going to hear me speak English, which is great. I appreciate that you're actually doing that. And I'm sorry I don't speak French. Well, yeah, you don't want to listen to me speak French. Okay. I'm going to take you through reasonable number slides about the transition from Java 8 to 25. Mostly it's technical, a little bit about why you might want to do this, but it's just going to try and give you a bunch of information. So the pro tip, if any of you ever want to have your toolkit be a speaker and get to Java 1, you just have to have a talk that names every tool that's in the JDK and every version. Then you get accepted, and that's what we've got in here. Most tools and a lot of the version information. So my name is Steve Poole. I work for a company called Herodevs, and we have a booth out there upstairs somewhere. We do support for end-of-life software, so any open source software you've got where there's no maintainers anymore, that's what we step in, and you can buy support from us. So that's cool. I work for Herodevs because I'm really passionate about software supply chain security and things like that. That's a different talk. I'm doing another one later today. And if you're interested in things like that, there will be more details, but that's just to let you know. I'm also in the process of slowly writing a book about practical dependency resolution with Hervé, who works as own type. He's a Maven committer, because it turns out that dependency management in Maven and Gradle and SBT and you name it is hard. So we're writing a book, and there's a QR code if you want to sign up to be told what's going on. The slides will be available at some point later. All right, so let's do the stuff. When you move from Java 8 to 25, it's not a version bump. We're all used to the little dot things and you make one or two changes. It's been a long time. And there's still people on Java 8. I'm not going to embarrass you to ask you to put your hands out, right? We have all the data, and it really is a significant set of changes because they've accumulated. The Java space is really good at trying not to break you. The Java development team is very good at trying to make sure that any changes are as seamless as possible, but there's always bits that change, and we're going to go through those. And I'm going to go through them in different orders. So I'm going to look in a minute about the tools that are available to you that you may not realize. I don't want too much time on the tools, but I want to go through more about the middle bit, about what's changed, and classify that basically on what won't start. Take your application, switch the JDK over, things don't start, talk about those. Talk about when it does start, but then it crashes, what causes that. And then the ones where you doesn't crash, it comes up, but you get a few unexpected surprises. There's a little bit like that. And then the last bit is some novelties, which are a bit of a gotcha, because if you think everything's working and then you happen to recompile, so if you took your Java 8 code, the binaries and ran it, you get, looks good, you recompile, and things don't work the way you expected just because you recompiled, and we'll cover a bit of that, and then a little bit of things. So a lot to cover in the time. So I will get cracking. The first thing is however much you may go, I'm on Java 8 or I'm not on Java 8, New Relic knows, and they publish the data, and we're still like 30% on Java 8, 30-ish% on Java 17, and hopefully the rest of you are something earlier, something more modern, rather than something earlier. So we've still got a lot of people who have to make the move. So how do you get there? Well, you need a bunch of tools to help you understand your circumstances, and there's reasonable amount of tools in the JDK that you can make use of. We're going to look at the static analysis tools like jdeps and things like that. I'm going to look at some of the runtime analysis tools because the JDK, the JVM, has things that it can do on your behalf to give you information. So we'll look at that. And we'll look at a few other bits and pieces. But let's start with jdeps. So jdeps is this wonderful little tool, and it has this JDK internals flag on it. And what you can use that for is to assess your code and your dependencies as to whether they're accessing things that you will not be allowed to do in the future. Right? So reflection internals, there are bits and pieces. So we're going to use this, or rather, I'm going to tell you where to use it to give you information. So jdeps is a tool that you're going to use to do this. So I don't want to really talk about the tools in too much detail. There's jdeprscan. I love the names. For removal. And this will look through and go, oh, so the JDK team have flagged things. This tool will tell you that there are things that are planning to be removed. So like security manager usage, we'll touch on that. Finalizers and things like that. So there's tools that will help you analyze your binaries based on what the JDK team have done or are planning to do. And they come for free with the JDK. Then there's jnativescan, another tool, came in Java 22, yeah, 22. So one of the things that you will need at some point is to do this -- enable native access, where the whole point here is to try and reduce the places where your code leaks out, accesses things that it shouldn't. They're for security reasons, there might be performance reasons, but generally the idea is to make that something that you have to enable. And so jnativescan will give you some hints on what you've got that you may need to do that. If you ran your code on Java 25, this is going to warn you, but the intent is that at some point, 26 maybe, they'll flip the switch. So this is heads up. So lots of the assertions and thoughts you may have had about how Java works on Java 8, things are getting tighter over time, and you need to know how to check those things, because you're better to do it statically than discover it at runtime and do all that revolving around the process. Java P has been in the JDK forever. Java P is another tool you can use to look at the class files you've got, class file versions and things like that. It's just a useful tool to understand. And again, I'll go through some of the reasons why you might want to use this. All these tools are in the JDK. They're there for you to use now, and they all have good reasons to exist. There's an external tool called JPMS, or however you want to pronounce it, which is for comparing two APIs. So you can take two jars and see how things have changed. These are tools that you might use when you start looking at, when you start updating dependencies and things like that, to get a handle on what's changed, because things do change. And this will help you get ahead. The idea on this set of tools is go figure out what's likely to break before you start doing anything. So it's a lot easier to have a shopping list of things to fix than it is to start and then discover things are broken. You might find the shopping list tells you need to think again about what you're going to do. And then there's a nice couple of little flags, and this is the most fun one. Lots of command line options on your JVM. Some of your command lines options on your JVM are no longer supported. So your JVM will not start. And so what you can do is use this wonderful XX thing to tell you what the final set of flags are, because obviously you can do pluses and minuses and things like that. And then you can look at what you're using today and compare that with whether or not those things are valid for running on Java 25 or whatever, right? It's there for you to use to work out what things you're going to hit before you start. Right. Runtime tools. This is really good. I mean, it's a tool. It's a command line option. This is really, really useful. This one, if you turn this on, every single exception will get logged, even the ones that you swallow. So unexpected errors in places that you weren't expecting, which might get swallowed by you or your dependencies, can be discovered just by doing this. So obviously you're not going to turn this on all the time, but again, it's something that you're going to do to give you a list of errors as you do those first migrations so that you're not surprised. Because there are changes in these places. And you're certainly going to see things like inaccessible object exceptions in circumstances, and it's a thing you're not going to notice. It's not something that JDK 8 is ever even going to thought about. Right. Another one, some misc unsaved memory access. It's all quite random, these names. Your ability to do stuff with native memory using unsafe is being as restricted as possible. Well, you can see the warning. You can start to ask the thing to tell you what problems you're going to get, or actually you can say, like with deny, you can say, let's see what happens if I ran in the future mode where it says I can't do any of these things. So you can turn those on, get feedback about your migration. And the point here is to get feedback as part of a migration effort, then to run it, and then it happens in production. Right. Java Flight Recorder. I put this in because it's important, but more to tell you that what you're going to impact, one of the things you're going to see is performance changes between Java 8 and 25, because the GC model is different, the object structure is different, technologies have moved on. And so one of the things you can do is just baseline your stuff with tools like this, or obviously there's a whole bunch of commercial things that you can go do instead. But it's something that's that you can use that's in the JDK. Right. As a side note, some of the changes that have been made, you can disable. You can turn them off. So there are some -D options that you can use, but all you're doing is storing up problems. It's much better to start dealing with them, because some of these things will affect your data. But you have the option, if you can't, to deal with it, to turn some of these things off. Right. So there are the 5 commands, ish, bunch of flags, some specific JDK commands, and most of these have a good reason for you to look at. They're almost all in the JDK, apart from the JAPI one, and they're available to use now. So you could start learning about how to do these things. Right, okay, so that's the tool set. They're available now. Let's talk about what's changed. Wow. Here we go. So I went through and said, what's changed? Just sort of tried to classify it by the various types of things, like will it start? Is it going to crash? Is it silent changes like that? So there you are, 9 to 17, there's a bunch of stuff, right? And that's what we're dealing with, lots of little changes. And then we have more. So 2 pages, okay, arbitrary screen slides of changes that are going to come through. And depending where you're in this, you are between 8, 17, and 25, you're going to hit these things, right? More or less. And so, as I said, I've grouped these into 4 categories so that it's easier to grok what's going on. And obviously, some of these things, you're just going to go, oh, okay, I hit that one. So let's do won't start. Okay, obsolete GC flags. I think I said at the beginning, you have GC flags in your launcher. They are obsolete. They are not supported. Boom. It won't start. So you have to figure out what they are and take them out. It's literally that simple. And of course, you've got to do that for every launcher that you've got, wherever it is, even if it's not under your control, you're going to have to do something with it. So there's a bunch of them there. And here is all the details. So this is the pattern that you're going to get from me now, is we're going to talk about the problem, and I'm going to give you a screen list of information you can use if you're interested to go find more. Obviously, all this stuff is properly documented, but I give you as many of the lists as I can. So that was one. The second one is Security Manager. You cannot specify Security Manager. You can't do the -G Java Security Manager thing because it will blow up, because it's not allowed. The Security Manager has gone. So if you try to use your own, which is possible, especially if you've got big application frameworks, you might have this happening. It's going to buff. It's going to stop immediately. And if you want to know more about that, there are all the details. There's enough people talking about this. I don't think anybody really uses the Security Manager. It's why we felt that it's easy to take out, because it's been a mess really from the beginning. More flags, obsolete GC logging flags. It's interesting to see, if you compare old with new, just how this stuff gets changed. And most of the time, the teams are trying not to break you, but there are times when they're going, well, we need to do something better, and we'd rather you move to the new thing. And the consequences to you is you've got to update it, you've got to change a launcher. And that's considered to be, not too hard. But because they've gone to this unified logging thing, you've now got some things that you've been using on Java 8 that just won't work anymore. Or thereabout, if you're interested. So that's won't start. That's not bad, is it? There's not too much going on. There are fair things you can pretty much figure out pretty quickly. And then there's hey, you got parts of that stuff, and you fire at the VM and it falls over. So what's it going to fall over on? Well, you're going to love this inaccessible object exception. It's the one that's going to hit you the most. You can see on the code you do f.setAccessible. Often, if you're doing reflection, this is the pattern you're going to do. You're going to get something, you're going to make it accessible, and then it's going to die. Right? You're not allowed to do that. If you want to do it, you have to add this add opens thing, and all you're doing is delaying a problem that's going to become even more prohibited. But it's the most likely thing you're going to fall over is because we all use reflection, we all use tools that do reflection. So it'll start, you run the first piece of reflection, boom. So it probably fell pretty quick. And there's all the bits to go with that. Right. Removed EE packages. Well, we all knew that was happening. We saw that happen. There's a whole bunch of annotations and classes that have just gone. Right? Java 11 took them away. So they're just not there. So the first point where you try and load them, you're going to get no class def found. So obviously, this is fairly major, but it's not something that you're going to discover until you run code because of the lazy loading, right? You can add your own stuff in. You can put your own classes back in. You can put them in your dependency tree and pick those up. If you use jdeprscan, you can go see how much of that you're using. Right? It's a problem, but it's a problem we all have to deal with because there's no easy answer. You move to the new stuff, or you add your own versions of the old stuff. More details. Nashorn. So Nashorn has changed enough, so it's gone. JavaScript engine is gone, but the way that you use it, you can see the code there where if you do get engine by name, you get null, right? So if you try to use it, and it doesn't matter whether you use Nashorn or JS or whatever, the basic values, it's not there. So you're not going to get told, you're not going to get an empty script engine, you're just going to get null. It's gone. Okay, pretty obvious failure when it happens. You're just going to get null pointer exception, and then you're going to be sitting there going, why is that? More reasons about why. And I said about the security manager, it's gone. So you can't do it on the command line. You can't call things like this, system.set security manager. You get new exceptions. It's gone. Anybody here actually think they use the security manager? Yeah, I mean, hopefully you don't. Your frameworks may. And there is a side issue here that if you have a framework using this, you might encounter. But you're basically going to hit this and it's going to fall over pretty quickly, because if you've got security manager in use, hopefully it's being executed pretty quickly. There's the details of why it's gone. You can use jdeprscan to find any usage of it, because that's what it's for. And hopefully you're going to be pleasantly surprised. This is a module thing. And again, anybody here using module path, using Java modules? Oh, look, a few hands. Yes, look at that. Okay, so they've changed the rules slightly. So split packages, which is where you've got packages in different modules of the same name, that is no longer allowed, and you get this nice, wonderful instantiation exception. You have to use the module path for that to happen. If you're using the class path, then you're not using modules. This is irrelevant to you. Okay, but there are ways to fix it. But it's the way to fix it is to move to the class path. But again, you have tools to discover it. This is just, if you're doing modules, this may bite you, especially if you've got multiple versions of something. And all that happens is you try to load something and it says yes, and you try to load something else and it comes from a different module, and the system will fail. I mean, it's again, fairly straightforward. But you have to exercise your code, load classes for this to trigger. Right. Again, more reasons for doing that. Right. Now this one, old bytecode information libraries, is a consequence of the decision by the Java team to bump the version number in the class files for every version, even if the class file format doesn't change. So it just goes up, dunk, 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 dunk. And that means that you have to make sure that the versions of any bytecode manipulation libraries you're using also have to move up, because they won't understand. For a long time, you could use an old version because the class file format hadn't changed and the version number hadn't changed. So that meant it was all going to work. But now, because every class file format, every time you recompile code, moves up, you're going to have to use the latest versions of this. So it's more annoying than anything else, but it's one of those things that you're very likely to see the first time, because suddenly you're accessing a whole bunch of class files that have new class file version numbers, even if the contents haven't changed. Again, a bunch of reasons about why that's happening and how to deal with it. So I said about native access. So the drive is to move you from the old ways of doing native access, JNI, unsafe and things like that, to more structured technologies. You will get warnings, right? Because the idea is that you have to do that -- enable native access, because you are going to have to opt in to making these changes. And right now you're going to get told off, and you may have, if you've been playing around with latest JDKs, you probably will have seen some of the error messages, warning messages that come out now that basically tell you this, right? So yes, you can enable it, but again, all you're doing is delaying. You're just hiding the warning, but you're not fixing the problem. Again, more JEPs, more information about it. And obviously, as I said, the JNative scan, Java 2.22 onwards, is what you can use to help analyze this stuff. Sun MISC unsafe. 79 of 87 unsafe MISCs are on the removal path. It's gonna go. They are cutting it down because it's a horrible thing. It should never have been there in the beginning. And I've been doing Java since it was knee high, and we've hated it ever since then. It's gonna go. You have to go through, take it out. You can turn on this memory access debug thing to see where you use it. Everything you find, you should be very, very focused on removing it, or at least moving all the changes to somewhere that you can manage later on. Okay. And of course, the trouble is a lot of these things are not going to be in your code, they're going to be in your dependencies. Right? But this is going to bite you. Right. And again, more and more JEPs. Okay, so most of that you're going to hit pretty quick. You're going to fire your application, it's either going to fail to run or you're going to run it, and hopefully most of the time, by the time you've exercised most of the class in your application, something like this would have occurred. And if you've got the logging turned on, so even if you've swallowed the exception, you know it's happened. So hopefully that's cool. But now there are changes where, as it says, it runs, but you get different behavior, and they're the dangerous ones. So this is a little one, but it might cause you problems. Because Security Manager has gone, if you are using the Security Manager, it means that the do privilege thing, if you've ever seen the code, you have to ask for privilege and then you run, that will always be true now. So you might find that you've got code that you're assuming that some thing will actually have to have privilege, and because there's no Security Manager and the Security Manager that exists is like, just do it, you could actually have code running that hasn't got privileges, but it's okay because you probably haven't got a Security Manager turned on. But it's there. You don't get an exception, it just runs. Right? Get more details about that. And now this is the thing that's starting to get to you. They've changed the locale data stuff. So this means that the format of the data that you create is changing. So you can see the before and the after. Right? This means that by default, you're going from the JR locale data to Unicode. So if you rely on the JDK or the JRay to just figure out what the right locale is and which one to use, that's the process for that has changed. So unless you take control and say what specifically you want, you're going to find that output is different. So you get, for instance, the examples are you get something like you get a nice string that you can go, okay, it's in English, but suddenly you're in a different locale, and so it discovers the actual locale, and now you get a different output. So you can imagine the consequences to your data if you don't realize that this locale effect is happening. You can turn it off. You can put this -G option and go back to old style. But if you don't, you're going to find places where quite literally your data is going to be different. And if you're expecting one behavior, obviously you could get a different behavior. Yep. And I think I've said that, but you get the idea. It's the code is the same, but the output is different. So you've got to keep an eye on that. You've got to go check out your use of locales and where you're relying on the default. If you're not taking control of these things, you're going to get a different effect. And there is the small amount of information available. Right. And it's same with jar sets. This UTF-8 is now the default. So you get the same thing. You get different behavior. The data looks different, right? So depending on what platform on, you could get different behavior. So if you're expecting common behavior across platforms, you might now realize that that's not the case anymore, and you're going to see different behaviors. Right? You can turn it off. You can put the -D file encoding as compat. You've got to go through everywhere where you're using file readers and file writers and anywhere where you're basically interacting in places where you need character sets, and work out what you're using and change your code. and potentially go through all your dependencies and get them to do that too. There are the things, right? I mentioned this about performance. So the default garbage collector has changed. What does that mean? It just means your performance profile is going to be different. Hopefully your performance is better, but just be aware that the GC things have changed and that moving from 8, 11, 17 to 25, be aware that it's not just, oh, I'm going to get good performance. You're likely to get different performance. Okay. And again, more things about that you can go read. Right, now, compact headers. One of the reasons that unsafe is because it goes straight down to memory and assumptions are made. And what happened was that the structure of objects in the heap, the actual internal structure, has changed, right? And so that means that where things were, how many bytes away from this was this next field, that location data has changed. So if you have code that just assumes that it knows this is at 0 and this is at 5 and this is at 10, that is no longer valid and it will break. And so when something like that breaks, you're going to get weird effects and you may not realize it. So again, it's that whole, if you're using unsafe, then you need to turn on this misc unsafe debug thing and get an understanding of what's going. It is one of the most dangerous things in here because it's the point where you've got rid of all protection and you're going straight into the heap, looking at objects the way you thought they were written, and now that's changed. So again, more details. Thread group degradation, which I think is just a great title. Thread group, the class, yeah, a lot of the methods you call just, some of them don't work, like destroy doesn't work, but now we're starting to get exceptions. So if you issue commands to thread group rather than thread, then you could find yourself getting a whole bunch of exceptions. And the thing is, thread group just doesn't do anything anymore. So you don't actually need to use it because you're not going to get any benefit. But all that's going to happen is you're going to get exceptions. So again, the only way around that is to go have a look at your code. And again, more reasons for that. Finalization, well, we're almost gone. Finalization. Finalization is one of those things that was a really good idea at the beginning for about 2 seconds, and then everybody realized why it had a load of downsides. I'm assuming that you're probably not relying on finalization anymore, but you can try it out. So you can do the -d finalization equals disabled thing and see if any of your code breaks, but that's what's coming. It's not something you should be using, and it's certainly going to be gone very soon. More details. Right, wrapping up. Recompilation surprises. So it's great to have the circumstances where you go, I've got to this point, we've moved our application, we made all these changes, we recompiled it against Java 8, we fixed everything, it runs on Java 8 and it runs on 25 and we're done. So you go, hurrah, and you recompile everything against the latest compile, and things break. And the thing that's going to break the most is serialization. So if you've ever, I say if you use serialization, we all use serialization, but if you've read all about everybody telling you should put a serialization version UID in your code, and you never did, now you're going to pay for it. Because when you serialize and deserialize objects, the first thing that happens is there's a comparison between the serialization used on UID in the data stream and the structure of your class. If you don't have one of those, that structure is calculated, that number is calculated. And the calculation for a class the calculation process has changed. So you can take a Java 8 code class and it will calculate it and give you the number you had in Java 8. If you recompile it, it's a different internal class file structure and you will get a different number. So when your new code tries to when you try to deserialize Java 8 structured data into this code, into this class, it will fail because the calculated number and the one that you had when you stored it have changed. If you put a serialization version ID in the code already, in your code, then you're done. Because even if you recompile it, but if you have one in Java 8, if you didn't have one in Java 8, you can't just add one because the data that you've serialized with will have taken whatever calculation it used. So you will have to go through every code that gets involved in serialization, look for those that don't have one, and figure out whether you have any serialization data somewhere outside your VM. And if so, you've got to fix it. It's nasty. There's the details for that. A few more bits and pieces, almost finished. Underscore. You could use underscore as a name, and as of release 9, so a long time ago, underscore became a keyword. I'm not sure I ever knew anybody use underscore as a version file name, but there we go. So now it will break. There's a weird thing around star imports. If you do import blah 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 .star, about some people reporting occasionally clashing. It's more to do with when you have classes which have the same name as an internal one, but the package class is different. So if you have your own internal IO class and you do public and you do import java.io.star, you might fail to compile now because you've got a class called IO and it's trying to import IO. Right? But they're all trivial things. You just may or may not hit them, but you're only going to hit them once and then you'll fix it. Right. String concatenation or evaluation. Another nasty thing. When you build strings, it used to be that the pattern of code that was created to build a string builder. So when you do string A plus string B plus string C, or object A plus object B plus object C and turn it into a string, the toString methods are being called. Okay? So obviously if it's a string, you get back the data, but if it's a complex object, code is going to run. And it turns out that even when you do A plus B plus B plus D, the actual internal order of how that list is constructed, it'll still end up with the right final sequence, but the order in which the classes get the parts get called has changed, and so you might find that some of you're just seeing your code being executed out of order. It's an edge case, but it's worth understanding that if you're relying, you probably aren't relying, but you could certainly not understand that you're relying on the order of code being executed as the two strings are called. Right, almost finished. The Lombard trap. There we go. Java C no longer runs annotation processors. Annotation processors turned out to be a horrible security hole, so they just turn them off. If you want them to run, you have to turn them on. So from a compile point of view, nothing will happen. You won't get any errors. You just won't get any Lombard generated accesses. So you'll know that pretty quickly. Okay. Nestmates, I'm going to skip this one because it's not really important. That's just because I'm running out of time. What else to tell you? If you haven't already looked at Open Rewrite, you should, because Open Rewrite has lots of the patterns you need to help you do a lot of this work. You certainly need to go have a look at that stuff. It will make your life a lot easier, and because a lot of it's already there. So finally, what can I say? The problem you're going to have is threefold. It's great for me to say, here's all the challenges you're going to have, and this is what you've got to get your code to fix. But your code is only 10% of your application. 90% of what's needed for your application to work comes from somebody else. So your biggest challenge is more going to be making sure that all your dependencies are on the same journey with you. And that's a bigger story, and that's the thing that's going to bite you more than anything else. The silent changes, the Unicode things and things like that, the serialization, they're going to bite you, and they're going to bite you in silent ways, and they're going to corrupt your data, which is the last thing you want. So you have to look at that. And then finally, just be wary that recompilation, yes, it will give you some performance benefits, that's for sure, because the class file format is better. The JDKs understand the class file format and will optimize that better than the JDK8 ones, but you run a recompile failure, a recompilation differences challenge. There we go. Why are we going to Java 25? Why not stop somewhere else? Because it's got a bunch of really good stuff, and it's got good long-term support. All the vendors support it. You just get a whole bunch of performance improvements generally out of the box. And as I said, it's got long-term support. Why would you not want to use this? Virtual threads, and 26 has even better virtual thread support, right? But in terms of an LTS target, this is the current one. And you really need to move up. You really need to start grappling with this, because if you haven't done it so far, the barrier just gets bigger. There we go. As I said, the crashes are the easy part. It's the silence you have to worry about. That's it. Thank you. Any questions? Any questions? In English, please. No? I can't see. Come to Devoxx France. I can't see anybody because there's bright lights. Okay, well, listen, I'm obviously around for a bit longer, because we all are. If you see me and have a question, just come and ask me. And I'm doing a talk at 2 about zombie dependencies. So if you're interested in something completely different, I will be there. Thank you.